This is Narsimlu Madhuri. In this lecture, I am going to discuss how to implement particle swap optimization neural network for predicting customer behavior in digital marketing. Let me go here. This is our project. So I am showing you how to implement this project. The agenda of this lecture is what is an existing system, proposed solution, the approach, process flow diagrams, architecture, or technical aspects, few code snippets I'll show you, sample screens, conclusion, feature, enhancement. Let me discuss one by one. What is an existing system? In existing system, predicting customer behavior in digital marketing, so that is display advertising, social media, native advertising, video data using neural network. In this existing system, so the author applied conventional neural network. So when we use a conventional neural network, which is not convenient for giving the better results, so that we are going for proposed solution, which is particle swarm optimization neural network for predicting customer behavior in digital marketing. Let me see here. So first of all, we should know what is digital marketing. Digital marketing refers to advertising delivered through digital channels such as search engines, websites, social media, email, and mobile apps. Digital marketing is the method by which companies endorse goods, services, and brands. What is customer behavior prediction? Customer behavior prediction describes the journey a consumer goes on as they research, select, and buy a product or service, or concerned advertisement is preferred or not by customer. There are some key terms in digital marketing. First, we'll see VAR framework. This is vector autoregressive model. This is a workhouse multivariate time series models that relates current observation of a variable with past observations of itself and past observations of other variables in the system. Coming to the B2B context, this is business to business context. ALM, economical learning marketing, will help grow business, non-profits, brands. Now, SEM method, search engine marketing, is the act of using paid strategies to increase search visibility, and brands pay for ads to appear as search results on search engine results pages. Now, the another one is content automation. Content automation is a digital marketing strategy that focuses on removing the need for human interventions in the marketing life cycle. Campaign marketing promote products through different types of media such as TV, radio, print, online platform. Now, another term here, influencing marketing, is a new mainstream form of online marketing. You know this SEO, search engine optimization method for searching. These are the main key terms in digital marketing. So first of all, we should know what data we have to use, what type of data is required for solving this project, for implementing this project. First, we have to get the data. So here I did research to get the data. So I'm just getting the data from here. So advertising ads, these data which contains information about advertising ads, like here daily time spent on site, age, area income, daily internet usage, a topic line, etc. These are the attributes which are there in this data. The approach I followed to implement this project: first, identification of data, meaning here in the data science, main challenging task here, identification of data. Once we identify the data, where the data is available, what data is needed for solving this particular business problem, this is a major challenging task. For that, we need to do a lot of study here. I did a lot of study on digital marketing data. So I identified the data. Now, predicting customer behavior in digital marketing data using particle swarm optimization neural network algorithm. This is the proposed solution for solving this business problem. This project we are implementing using particle swarm optimization neural network. Here the data is available here. Once we clicking on this URL, it is directly navigating to the respective directory. Let's see here, once I clicked on that, directly it is navigating to that respective URL here. Now we can see the data. These data which consist of 10,000 observations. This is data here. Here we can see the data here. Here we can see the data here. So we can download the data from here. So once we download the data, that data we can add it to our drive for fulfilling our task for implementing the project. So this is what here, right, with this URL. The next, this is a data set. It contains 1000 observations and 10 columns. In that, here there is a column here, daily time spent on site, age, area income, daily internet usage, add topic line, city, mail, country, timestamp, clicked on. Add, this is a target label. Among these 10 attributes, 3 are float, 3 are integer attributes, 4 are object attributes. So we are applying supervised algorithm, so which is a classification algorithm. Supervised algorithm classified into classification models and regression models. The classification models are again classified into binary classification, multi-class classification. Binary classification, dependent variable discrete value is a binary categorical which is 0 or 1. In this project, ad, that is advertisement, is a dependent variable which has true or false categorical values. Regression model which is applied on continuous dependent variable. The variable is continuous, then we'll apply a regression model. That is target variable. Now let's see the algorithm. So how we are going to implement using this algorithm. First of all, we should understand neural network functionality, then we'll go for PSO algorithm. What is neural network? First of all, we should know what is neural network. Here, neural network is an interconnection of nodes analogies to neuron of brain. Unlike human brain, nodes are placed and connected to each other in layered manner. It is a cascaded layers of nodes where each layer has different number of nodes in it. Here, see this. This is one node of neural network. The strength of connection, this is a strength of connection between any two nodes is determined by the weight associated within it. See here, this is the input here. Here we have weight here. The bias is a constant. It can vary 0 to 1, or we can take any constant value. So here input is multiplied with the weight, and we are adding here, this is output we are getting. This is a one node of neural network. Like this n number of nodes that is interconnected with each other, it becomes a neural network. Neural network is a iterative process of operations on input, where each operation is multiplication of weights followed by addition of biases to get desired output, which we have seen in the previous diagram. Each iteration defines a layer of neural network. Different weights and biases are used in different layers of neural network. Output of each layer is passed through function called activation function. The activation function which is activated the input and multiplication with the weight and bias. It is activated using activation function. These activation functions are used to bring non-linearity into the neural network. This is a simple diagram here. This is a, so when the network is in linear, so it is network is in non-linear, which is bringing into the neural network using this diagram here. Y is equal to this is our m1 into x1 plus m2 into x2 plus c here. Here x1 x2 are inputs, m1 m2 are weights, the c is a bias. These are the standard activation functions. We can use it in our neural network here. So log sigmoid, softmax, rectifier linear, that is a ReLU function. This is x1, x2 are input here. This input here. Neural network is interconnected with the nodes. Now y is a predicted. It is activating the functions. Here we have function, here we have function, we have function for activating this, for activating this, for activating this, for activating this. This is the final outcome. Here weight and the bias. See here, yeah. This is a 2-3-1 neural network, meaning here two inputs here, these are the activations and one output we are getting here. This is 2-3-1. This is the architecture of our neural network. In the neural network, supposed to produce the better activation or better results, to optimize the error. So what we have to do, we have to change the weights and the bias such that final error term, that is optimized function, is minimized using a gradient descent method. See in this diagram here, so in that it may get stuck at the local minima of error function. So we converge to a global minima instead of a local minima, because if we use multiple agents, then there is a high probability that some of them will reach here, some of them will reach. So that's why we have to use multiple agents to get a global minima. So this is a basic intuition behind particle swarm optimization. So behind the particle swarm optimization, we use this basic principle to implement PSO for training a neural network. What is PSO? First of all, we should know what is a PSO. Particle swarm optimization is a metaheuristic algorithm. PSO is a population-based stochastic searching algorithm. PSO is inspired by social behavior of birds flocking. Here, flocking means here moving together in a crowd, that is flocking. Birds are moving together in a crowd. So this is a basic principle of particle swarm optimization. PSO searches for the solution in given search space which optimizes objective function. Each particle which has several properties. Particle is an object. Particle is an object. That object which has properties, several properties. A particle is a set of weights for the network. What is swarm? Swarm is a group of particles. What is meant by search space here? Search space is a range in which the algorithm computes the optimal control variable. When any optimal control value of any particle exceeds the searching space, the value will be reinitialized. Now coming to the objective function. The main criteria of PSO algorithm is minimize the objective function. What is an objective function? Objective function is used to maximize or minimize the values that we are trying to optimize it. Now each particle which has a velocity here, this velocity, each particle have velocity here, meaning here in which direction the particle is moving, which direction the flying of the particle, meaning here in which direction the particle is moving to reach the better solution, best solution, that is a global minima. Minima is here optimized value. Local and global best, I'll see in the diagram. I'll explain you what is local best, global best. I'll show you in the pseudo code. I'll explain you. These are the properties for any particle here. Particle which has a frequency, particle which has position, particle which has velocity, pulse, loudness. These are the properties of particle. Now, so this is the formula for calculating the velocity of a particular particle. Now here write the present particle, then randomly selected value. C1 is a local acceleration constant. W is the inertia factor, because to move any particle to get the optima value, so we have to apply inertia. Velocity, this is Vk of I, velocity of ith particle at k time instance. C1 is local acceleration constant. This can be called as a learning rate. Local best. Local best means here this is the best value for a particular particle. Local best position obtained by ith particle till k time instance. Now x is a position of ith particle at k time instance. This is what number of inputs here, position, and C2 is a global acceleration constant, which is also a learning rate here. Global best position obtained by ith particle till k time instance. So we'll see this with an example. Now this is a pseudo code for PSO algorithm. First we have to define search and objective function, then create particles in search space and initialize their position and velocity randomly. Let us assume there are 60 students in a class. The class teacher is conducted the test. Let us assume here first test and second test. Now among the 60 students, a student returned the test. First time he got 42 marks. 42 marks. B student in first test he got 90 marks. Here A is a particle, meaning here first person, best score at this moment is 42. Now here first update velocity. Now the particle is initially constant, then here we need to update the velocity. First initialize their position and velocity randomly. It is initializing the values randomly, either 0 or 1 from the search space. So loop is repeated till because maximum number of iterations. When it reaches the maximum number of iterations, we are coming out of the loop. First each particle we are doing this. First updating the velocity. Initial velocity is, let us assume here 0 or 1, but in the first test here he scored 42. Is local, meaning here P best, particle best. This person best score is 42. Then B scored 90 in the first test. His best score at this moment is 90. That is called P best, local best. Now in the second test, the person A scored 86. Now here let's see a new position within a search space, update the position. Again we need to update the position here, calculate the cost value. If cost is less than local best, we need to update the local. Now here which is the best here among these? Now previous best is 42. Then in the second test his best is 86. So here we need to update the local best. So here ending this. Now coming to the same thing here for global best also. Global best. Now for B also we need to update for local. Then coming to the global best, among these values here 86 and 96 and 42 and 90, here which is a global best. Among these values 96 is a global best. So with that, so we are updating it. It's keep on updating the local and global till maximum number of iterations. Like this our particle swarm optimization algorithm will work. I hope this is a simple flow of particle swarm optimization algorithm. Parameters, so initial inertia weight, acceleration constants, that is C1, C2, these constants also called as learning rates here. And topology structure is a global star, a local ring structure or other structures. This is what PSO 2D search space here, how it is searching for the best solution minimum value, because it is taking the particles here, from them it is going to minimizing the error by iterating it, keep on iterating till n number of particles to get a better results. This is what algorithm is working. Here in the previous diagram I have shown you 231 neural network. Let's calculate the total number of unknown parameters in neural network. Here unknown weights we are calculating 2 into 3 plus 3 into 1, that is what, 9. Now coming to the bias, 3 plus 1 is equal to 4. Total number of parameters in that network is 13 here. Thus we create 13 dimension search space in that network. We randomly initialize the particles in the search space. So because we need to take 13 dimensions here, that 13 dimension positions of this particle is one of the structures of neural network. The objective function which we used in PSO algorithm is to minimize final error term, that is predicted value and the actual value. If this value is minimum, so reducing the error. So our objective function main aim is to minimize the error. So we move all the particles iteratively such that error value associated with each of them decreases in each iteration. Finally here global best solution is our solution to train a neural network. This is what we applied a or so 0 or 0 0 0 or 1 1 1 or 0 1 1 or 1 1. This is a neural network output here after training that. Now advantages of PSO here: easy to implement, only few parameters are used in PSO, only few parameters, and successfully applied in functional optima, that is, and artificial neural network training and fuzzy control system. Converges faster than genetic algorithm. The one disadvantage of PSO, that is particle swarm optimization, is do not guarantee an optimal solution ever found. This is only the one disadvantage of PSO algorithm. So this is what process flow. I took the Kaggle data which I have shown you in the earlier slide. Kaggle data. So first of all we need to collect the data. So I collected the data from Kaggle. So in the Kaggle identified the data, which data is suitable for my project. I have selected that is online advertisements. Here I have taken the data here. That data we need to process it, that is called data pre-processing, because the data may be in a different format. We need to bring the data into our required form. So using a data pre-processing techniques, that we need to do it. Then we need to select the model and we need to train that model. So is a particle swarm optimization neural network. We need to build it. Evaluation of model. So this evaluation of model phase, in this phase we will evaluate the model using a matrix. Here we have to use classification matrix here to evaluate the model. How best the model is giving the results, that is what cross validation we need to do using classification matrix. Here used accuracy score is one classification matrix to measure the quality of my algorithm. Another one is confusion matrix here, which is classifying the which is measuring the quality of my algorithm here, which is confusion matrix. In data visualization, what we'll do, we'll explore the data. Why we are exploring the data here? So exploring the data to understand the missing data. What data is missed in our entire data set, that is exploring missing data. Another one is describes each column data here, and explore categorical or numerical, that is continuous variable for each column. To explore that, so we will use this data visualization. And another important thing is to correlate the target label and the independent variables. We need to we need to correlate the dependent variable and independent variable to understand which is a primary attribute to predict my output value. So that is also very important in data visualization, to understand how strongly our variables are depends one to each other, that is correlation. In data pre-processing, first we have to identify the missing values. So is the missing value is numeric, that missing value we can replace with the mean. If the value is, if missing value is if the data is in numeric form, we can replace with the mean here. If that missing value is categorical, so we can replace with the mode. It depends upon the number of missing values. And another important thing here, this one, encoding the data. We have to encode the data, that is categorical data. We can use a binary and label encoding, one-hot encoding. And another important thing in data pre-processing is feature scaling. The data is in right form, so we need to scale that data. So that is, we need to standardize the data here. If the data is in a right form, we need to standardize it here. For example, some of the values are in integer form, some of the values are in float form. We have to bring it into standardized form using the standardization techniques here. Another one is normalization. The normalization, as we know, that which is used to remove the duplication in our data. So if there is any data is in repeated, too many values are repeated in the data set, so by applying this normalization technique we can remove it. So we need to normalize the data if the data is in right form, right? So this is data pre-processing phase. This is a proposed model for predicting customer behavior in digital marketing. So what I did here, I collected the online advertisements here. So it could be in any online advertisement. Here I took the data, so applied the data normalization. So because the data is in a right, the data is not in a right form, we need to bring the data into the right form to get a better results. Because if you give a wrong data to our model, so the model will not give a proper results in future. That is the reason we need to bring the data into right form. So the data normalization is used to remove some duplications. If there is a noise data is there, if is there any duplication data is there, we have to remove using this data normalization. So here, so prediction by neural network. So we are training this neural network using this particle swarm optimization algorithm. Then here, so finally it is classified into whether that advertisement is preferred by the concerned customer or not. So we have to classify. This comes under binary classification. This is a process flow of particle swarm optimization. First, as I explained in the pseudo code here, first of all we have to define the objective function to be minimized, initialize the parameters of PSO, that is we have to randomly initialize the parameters like position and velocity. So then iterations. We need to keep on iterating till end of the maximum number of iteration, that is iteration gets incremented. And calculate the objective function and update the parameter. We need to update the position, we need to update the velocity, we need to update the local best, we need to update the global best. That is what update the position and velocity of the particle. Check the predicted and target output according to the error limit. If it is yes, we need to calculate the objective function. Again, to minimize that error rate, we need to update it. If not, what you do, PSO is the solution of economic load dispatch problem. Here, our PSO is a solution for this project. So this is what process flow particle swarm optimization. Here in the network, how it is working, x1, x2, these are the inputs. Let's say here, so here x1 is one particle, x2 is another particle. Here we are giving it to the hidden layer. So apply PSO algorithm on this. So we are getting the output, and output 3. So this output we need to compare with the actual output. If the error rate is minimum, so that is the best solution. If not, we need to update the objective function as well as other parameters. This is what PSO process flow, actually bias value, the input 1, input 2 and input so on j. Hidden layer, first we are taking the input 1 and the bias value, then in this, so first input and the next node here, so that is 2 here, like that 1 2, yeah. So same thing like here also, it is computing the output. This is a use case diagram. Here first gather the data from the source. Once we got the data, we need to prepare the data into our required form. So if there is any missing data is there, if there is any attribute is not predicting the output value, so that also we can remove it. That is called deleting the data set, means deleting the column which are not required for our prediction. So we need to identify the primary and non-primary attributes for predicting the output variable. So select the algorithm, examine and update till we satisfied. So this is model prediction. And coming to the technical aspects here, so I use a Google Collaboratory here. So I'm just using the data here, which is advertising data. So I use the algorithm here, particle swarm optimization neural network for predicting customer behavior in digital marketing. I use the language here for implementing this algorithm, Python. I used it here. Here PSO neural network for predicting customer behavior in digital marketing data. First, go to Google Colab. So we need to load the data here, visualize the data here. So we need to apply data pre-processing technique, separate the training data and test data. So we need to select the model and build the model. So build the solution. This is what we have to do for implementing this. Let me see the implementation part. This is what here, these are the libraries which are required for our project implementation. I use a pandas, matplotlib for visualization, pandas for loading the data, seaborn for visualization purpose. This is a rich visualization library for exploring our data. So this is for creating a n-dimensional array with numerical values. These are the required libraries here. So I use this sklearn library here for model selection, splitting the data. I use this. Then next is here Here I load the data here. I load the data from the drive here. So here I have 1000 observations, 10 attributes. Suppose to know about the data description or information about the data, just we have to use the function called here info function, which is giving what type of data is there. So here it is showing in the entire data set I have 3 float values, 3 integer values, 4 object attributes. Now these are the columns which I have in my, this is the data here. Now I'm exploring the age here. Which age group is most frequently preferring the advertisement through online? So to know that, here it is exploring my data. I'm exploring this data here. Next here, this is exploration about the area and as well as a area, income and age. This is exploration about age and daily time spent on site to see the advertisements. This is a target label comparing with all attributes. Here 0 for preferring the not preferring the advertisement, 1 for preferring advertisement, concern customer. So this is a attributes. These are the attributes. These attributes are primary attributes, meaning here I am taking 5 attributes here. This is a 5 columns which are predicting my output variable. So I split the data into training and test data here using this train underscore test underscore split function by passing the parameter x and y. This is capital Y. So this is a shape of my input data here. 1000 observations, 5 columns, 1000 observations, 1 column here. Here I am taking 20% for testing, 80% for training. I used it here. I defined the function from the scratch, that is a particle for each input here. So this is a class, I defined it here. In this class I defined the constructor. This constructor will be called automatically when I create a object for this particle class. Here this, and again I define this fam here. This is group of particles which are inculcated the in this swarm class here. Optimization, I define the function optimize function to optimize the error rate here. So here function to be optimized used in forward pass here. This is my function for optimization. Get best solution, use this here. This is what training here. Now I'm training my algorithm. Here input nodes are 5, meaning here number of inputs. Input mean here columns. Here I'm giving 5 columns here. 25 hidden layers I'm taking here. 2 outputs, either advertisement is preferred or not. This is the function. I use the activation function softmax, and this is a cross entropy. This is a function here. Weight and the bias. This is again I define the function predict function and get the accuracy here. I define it. Here I am getting the accuracy here. Global best loss here only 0.1. This is a loss function. We minimized it here. First iteration, the first iteration, that is up to 101 the iterations. The last value is 0.9, only 0.7, then 0.7, 0.8, 0.6, because in each iteration we are reducing the error by updating the parameters and as well as objective function. So the finally we got 0.1. This is a less comparatively other iterations here, so I use 1000 iterations here. This is accuracy here. Classification report is this. This is my classification report here. 0.97 is my accuracy on this. Coming to the conclusion part, for predicting the customer's behavior in digital marketing by optimal trained neural network, the data was gathered from various formats regarding diverse advertisements such as display advertising, social media, native advertising, video, and etc. So PSO, that is particle swarm optimization neural network, is performing well in customer behavior prediction under digital marketing. In the future, the significance of deep learning could be applied for better mining of customer behavior prediction. So in future enhancements, this can be further extended by using other models also, and it can be deployed and Flask web framework. So these are the references I used it here. These are the references I used it for solving this problem, for solving this project. I use this reference. Dhanyawad. If any queries, contact on this mobile. You mail me on this mail ID. Feel free to ask me. Dhanyawad.